Okay, so if we look at our clade that we just drew earlier and talk about what the derived and versus shared traits might be, we could think of probably a whole bunch of them, but I'm just going to go over one of each so you kind of get the idea. So the shared primitive character that all of these have, so something that existed before all of these different types of organisms evolved. So down here, with these ancestors down here, whatever they were, they all had fur. Okay, fur is not something that's particular to raccoons, red pandas, giant pandas, and bears. Okay, right? They all have fur, but so do a lot of other things. Okay, so this is our our shared primitive character. Okay, so that fur was our primitive trait. Now let's think about what a derived trait is. Now, I actually had to look this up because I'm not that familiar with what raccoons, red pandas, giant pandas, and bears all have in common. But it turns out that they have a special type of foot. Okay, it's called a cat foot. Oops, back up here a second. Make sure I have my pen. Okay, so they have something called a cat foot. And why does it not want to write? Let's see if I can get this sorted out here. Okay, let's try this one more time. There's our writing. Okay, so they have something called a cat foot, even though they're not, closely related to cats or anything like that, but their feet kind of have that same appearance. It's called caniform or something like that. So they all have this special kind of foot. And if you've ever seen raccoon footprints, you kind of know what I'm talking about, right? They almost look like a little foot that kind of looks like this. And then they have these little claws on the end. Okay, it turns out that pandas, giant pandas, in particular red pandas and bears, have a similar type formed foot. Okay, so our cat foot is our derived character for this group. So this is a new trait that showed up with this clade or this group of organisms. Right? So fur existed beforehand, that's primitive. The cat foot existed with this group only, and so that's considered derived. And make sure that you understand that, and if you need to label that in your own cladogram, please do that while I erase. Okay, a couple other new words. Outgroup versus in-group. Okay, when we're making a cladogram, it's helpful to compare organisms that have the same traits to those that do not, so that we can see kind of where those derived and shared characteristics come up, where they start or where they begin. How do we know that, for example, fur is a derived group for the pandas, but that fur is a primitive trait, but the cat foot is a derived trait. So we use this outgroup versus in-group kind of classification. So our outgroup, again, is a species or group of species that's closely related to the in-group. Now it's acting up again here. There we go. Okay. The outgroup is the species that's being studied. Okay, so you want to pick one particular species that you're looking at, or group of species that you're looking at, and find something that's not part of that clade, but is closely related to the clade. You don't need to write this down, but this is the reason we have that. Okay, and I'll show you how this works in a minute again with a diagram. But what you can do is you compare each in-group species of that clade with the outgroup to figure out, okay, what were the derived characteristics and what were the primitive characteristics. Alright, so here's an example of that. I'll kind of guide you through this so you can kind of get an idea of what we're looking at here. We've got down here at the bottom, along the side, it says this is what our character table is. So these are the traits that we're actually looking at. So our different traits are, does it have a backbone? Does it have hinged jaws? Does it have 4 walking legs? Does it have a shelled egg? And does it have hair? Okay, so those are the traits we're looking at. Our outgroup is the lancelet, which is kind of like a fish. But as you can see, if you go down these traits, it doesn't have a backbone. Okay, so it's very similar to a lamprey, which is right here. That's our next in-group species. So lamprey, tuna, salamander. Oop, I didn't want to do that. Salamander, turtle, leopard. Okay, all of those are considered our in-group species. The lancelet is the outgroup. It's very closely related to the lamprey, but it is different because, as I said, it does not have this backbone. So if you look here, hair, no eggs. Well, no shelled eggs. Doesn't have 4 legs, doesn't have hinged jaws, it doesn't have a backbone. Okay, so that gives us a clue that the things that lancelet has are the primitive characters, and then once we start moving away from what that lancelet had, we're talking about derived characters. Okay, so the derived characters for this whole group, let me erase them here so that we can get around this writing a little bit here. Okay, so if we look at this group of just the leopard, lamprey, tuna, salamander, okay, their derived characters are the backbone. So we have got the lamprey has the backbone, the tuna has a backbone, the salamander has a backbone, turtle has a backbone, and the leopard has a backbone. So they all have a derived character of a backbone. Now if we move up and just look at the group that's the tuna, salamander, turtle, and leopard, so we make our clade a little bit smaller, they have the derived character of hinged jaws. Okay, the lamprey does not. You look below the lamprey, 0 for hinged jaws. It does not have that character. Okay, so it's not in this next clade. However, these top 4, tuna, salamander, turtle, leopard, do. So their derived character that they share in common is hinged jaws. You keep going up and find those different characters as you go up the steps, basically. That turns into a cladogram. Okay, so again, down here at the bottom, it shows the lancelet is the outgroup. Okay, and as we go up, we can see the derived characters and how they appeared in those different organisms in the cladogram. Okay, as far as what to write for this, I would do maybe just a little example of this particular cladogram down here. It doesn't have to be the full thing, but a short one. For sure have your outgroup on there. Show that the lancelet does not have that vertebral column, that backbone. Okay, so that's what makes it the outgroup. And then maybe show a couple levels of derived characters between the different organisms. And as always, of course, you don't have to draw these organisms. I should have said that earlier. Just the names of organisms is fine. The drawings are nice for your book diagrams, but for our purposes, you don't really need to do that.